Geology of the Great Smoky Mountains by National Park Service. Between about 310 and 245 million years ago, the eastern edge of the North American tectonic plate collided with the African tectonic plate, becoming part of a supercontinent known as Pangaea. Continental collisions take place at a rate of a few inches per year over many millions of years and are the results of continuing global-scale plate tectonics. Evidence of earlier plate tectonic geological events are found in the rocks of the Great Smoky Mountains, attesting to an incredibly long and active geological history in this area. During one of these earlier continental collisions, tremendous pressures and heat were generated, which changed or metamorphosed the Smoky's sedimentary rocks. For example, sandstone became recrystallized to metasandstone or quartzite, and shale became slate. The last great episode of mountain building uplifted the entire Appalachian mountain chain from Newfoundland, Canada to Alabama. These mountains probably were much higher than today, with elevations similar to today's Rockies. As the African tectonic plate gradually pushed against the edge of the North American plate, the original horizontal layers of the rocks were bent or folded and broken by faults. Huge masses of older, deeply buried rocks were pushed northwestward, up and over younger rocks along a large, nearly flat-lying thrust fault, known as the Great Smoky Fault. Following this final episode of Appalachian mountain building, the supercontinent of Pangaea broke apart, and the North American and African tectonic plates gradually moved to their present position. The new rugged highlands, the ancient ancestors of the Smokies, were subjected to intense erosion from ice, wind, and water. As mountain valleys were carved, tremendous quantities of eroded sediment were transported toward the Atlantic Ocean and Gulf of Mexico by rivers and streams. Some of these sediments formed our Gulf of Mexico beaches. As the mountains were worn down, the layers of rock most resistant to erosion were left to form the highest peaks in the Smokies, such as the hard metasandstone on top of Klingsman's Dome. Most of the beautiful waterfalls in the park were formed where down-cutting stream encountered ledges of very resistant metasandstone that erodes more slowly than the adjacent slate or metasiltstone. Today, geologists estimate that the mountains are being eroded about 2 inches every 1,000 years.